Lesson 1. Numbers and Numeration. Hi children, you have already learnt up to 4-digit numbers in your previous class. Now you will learn 5-digit and 6-digit numbers in this chapter. So, before going ahead, can we revise first? Yes, of course. The largest 1-digit number is 9. The largest 2-digit number is 99. The largest 3-digit number is 999. The largest 4-digit number is 9999. To obtain the smallest number for any number of digits, we add 1 to the largest numbers of the preceding digits. 9 plus 1 is 10, the smallest 2-digit number. 99 plus 1 is equals to 100, the smallest 3-digit number. 999 plus 1 is equals to 1000, the smallest 4-digit number. 5-digit numbers. On adding 1 to the largest 4-digit number, we get 9999 plus 1 is equals to 10,000, the smallest 5-digit number. The smallest 5-digit number is 10,000 and it is read as 10,000. Similarly, we can develop numbers beyond 10,000 as under 10,000 plus 1 is equals to 10,001. 10,001 plus 1 is equals to 10,002. 10,002 plus 1 is equals to 10,003. 10,099 plus 1 is equals to 10,100. 10,100 plus 1 is equals to 10,101. 99,998 plus 1 is equals to 99,999. 99,999 is the greatest 5-digit number. Representing numbers on spike abacus. We have already learned in class 3 the representation of 4-digit numbers on a spike abacus. Now we shall learn how to represent 5-digit numbers on the abacus. Observe how 5-digit numbers 24356 and 72094 are represented on the abacus.
In 5-digit numbers, the first 2 digits and the last 2 digits are read together.
Reading and writing 5-digit numbers. This is how we read a 5-digit number. 26,285. It is written as 26,285. This is how 26,285 is represented on the abacus. Place value and face value. Place value. The value of each digit
depends on its
position, place in the number. Every digit has a place. Example, write 5-digit number 36,218 in the place value table. This is the short form written in figures, which actually means
36,000
plus 2 hundreds plus 110 plus 8 ones, or
the place values go on increasing from right to left.
Value of each place on the left is equals to 10 multiplied by place on its right. Face value. The face value of a digit is the value of the digit in the number. Example 1. What is the face value of 9 and 5 in 35,296? Solution. The face value of 9 and 5 in 35,296 are 9 and 5 respectively. Periods. In the given table, the place values are divided into 2 columns called periods. We group ones, tens and hundreds under ones period and thousands and 10,000s under thousands period. We use a comma to separate the 2 periods. So, 46,728 is written as 46,728. 6-digit numbers. Following the pattern discussed for 5-digit numbers and moving ahead, we get 9 plus 1 is equals to 10, 99 plus 1 is equals to 100, 999 plus 1 is equals to 1000, 9999 plus 1 is equals to 10,000, 99,999 plus 1 is equals to 1 lakh.
1 lakh is the smallest 6-digit number and 9,99,999 is the largest 6-digit number.
Numeration. While reading numbers, it is always easy to use words instead of reading individual digits. For example, instead of reading 34536 as 34536, it is easy to read it as 34,536. In case of 6 or more digit numbers, the reading pattern changes according to the countries. There are two commonly used methods of numeration. These are, first, Indian system of numeration, second, international system of numeration. Indian system of numeration. In this system, we split up a number into groups of periods starting from right called ones, thousands and lakhs. The place value chart in Indian system of numeration is given below. From the previous chart, we observed that 10 ones is equals to 110, 10 tens is equals to 100, 10 hundreds is equals to 1000, 10 thousands is equals to 1 10,000, 10 10,000s is equals to 1 lakh, 100 ones is equals to 100, 100 tens is equals to 1000, 100 hundreds is equals to 1 10,000, 100 thousands is equals to 1 lakh. Example, arrange the digits of these numbers in the place value chart.
Solution. We can arrange the given numbers in the place value chart as shown below.
Reading a 6-digit number. To read a number, read together all the digits lying in the same period and also the name of the period, except the ones together. Writing a 6-digit number. If we group the digits into periods according to their places using commas, we can write a large number more easily. In modern notation, a short place or gap or blank is given between the periods instead of using commas. Example, write the following numerals by separating the periods. A. 344589, B. 594270, C. 270515, and write the number name of each. Solution. Separating the periods of ones, thousands and lakhs from right, we have read as A. 3,44,589, B. 5,94,270, C. 2,70,515. Place values and expanded form. A 6-digit number has 6 places. The place value of each digit in 363982 is, we can write the number in expanded form as
3 lakhs
plus
6 10,000s
plus 3
thousands
plus 9 hundreds plus 8 tens plus 2 ones. Representing 6-digit number on the abacus. Example, represent 4,20,753 on the abacus. International system of numeration. In this system, the place value is different from Indian system of numeration. The place value chart is given as follows. Example, arrange the digits of these numbers in the place value chart. A. 278356, B. 364376, C. 899734. Reading and writing numbers. While writing, we group the ones period and the thousands periods. We use comma or a space to separate the two periods. While in case of reading numerals, we read the thousands placed together, followed by hundreds, tens and ones. Example, write the following numerals by separating the periods. A. 34526, B. 295105, C. 733347. Solution. Separating the periods of ones and thousands from the right, we have A. 34,526, B. 295,105, C. 733,347. Comparing systems of numeration. In the previous class, we have already learned some similarities and differences between the Indian and international
systems
of numeration. Let's compare the places of both
the systems
in detail. Indian system, 10 lakh, lakh, 10,000, thousand, hundreds, tens, ones. International system, 100 10,000s, 10 10,000, thousand, hundred, tens, ones. Now we can easily compare the places in both the systems. Example, find the place value of each digit in 384653 in both Indian and international systems of numeration. Solution, Indian system of numeration, 3,84,653. International system of numeration, 384,653. Up to 10,000s place, both the charts follow the same style. The lakh place and 100,000 place are equivalent. For example, 1 lakh, 100,000, 3,40,719,
340,719, 8,26,350, 826,350.
expanded form and short form. You already know how to write 5-digit numbers in expanded form. Here you will learn how to write 6-digit numbers in expanded form. Example, write 253469 in expanded form. The place value of each digit in 253469 is equal to 2 lakh plus 50,000 plus 3,000 plus 400 plus 60 plus 9 is the expanded form of 253469. Ordering of numbers. In class 3 we have learnt how to compare two 4-digit numbers. We follow the same rules while comparing two 5-digit or 6-digit numbers. Rule number 1. The number having more digits than another is greater. Example, compare 98562 and 235921. 98562 is a 5-digit number, while 235921 is a 6-digit number. Hence, 235921 is greater than 98562, or 235921 is greater than 98562. Rule number 2. If the numbers have the same number of digits, then start by comparing the extreme left digit. The number with the greater digit is greater. Example, compare 73457 and 52698. Since 7 is greater than 5, 73457 is greater than 52698. Rule number 3. If the digits on the extreme left are the same, then compare the next digit to the right and so on. Example, compare 362592 and 387634. Solution, both are 6-digit numbers. The first digit on the left is same in both numbers, namely 3. Now, compare the second digit. It is different. Since 8 is greater than 6, 387634 is greater than 362592. Ascending and descending order. Ascending order means arranging the numbers from the smallest to the greatest. Descending order means arranging the numbers from the greatest to the smallest. Example 1. Arrange 52156, 48801, 63185 and 100512 in descending order. Solution. On comparing the numbers, we find that 100512 is a 6-digit number and the rest are 5-digit numbers. Formation of numbers. We can form numbers with different digits. Example, form the largest number with the digits 3, 4, 7, 6 and 8. Solution. The largest number formed is 87643. If we put the numbers in reverse order, we get the smallest number. Formation of the smallest or the greatest number using the given digits when repetition of digits is allowed. Rule. To write the smallest or greatest number using the given digits when repetition of digits is allowed, first form the smallest or greatest number using the given digits
Each.
only once without repetition. Then, in the number so formed, replace the digit whose repetition is allowed by the number formed by repeating that digit the allowed number of times. Example, write the smallest and
The greatest 6-digit number.
using the digit 4, 8, 2 twice. Solution, greatest number formed 884422, smallest number formed 224488. Remember, if the smallest number is to be formed with one of the digits as 0, then put the number 0 in the second place from the left. Thus, if the digit at the leftmost
place is to be repeated twice,
then the repeated digits lie on either side
of the 0
in the second place. Skip counting in tens, hundreds, thousands, 10,000s and lakhs. 1. On skip counting in thousands, change the thousands digit. Example, 2865, 3865, 4865, 5865 and 6865. Second, on skip counting in 10,000s, the 10,000s digit is to be changed. The rest of the digits remain unchanged. Example, 1,23,000, 1,33,000, 1,43,000, 1,53,000. Third, on skip counting in lakhs, we only change the lakhs digit. The rest of the digits remain unchanged. Example, 1,37,835, 2,37,835, 3,37,835, 4,37,835. Rounding off numbers. Rounding off a number to the nearest 10.
To round a number to the nearest 10,
we name the nearest multiple of 10. Let us revise what we have learnt earlier. Sometimes we need only a rough idea of a number in place of exact one. So, we round off the numbers to the nearest place. Example, round off each of the following numbers to the nearest 10. A. 394, B. 346, C. 4765. Solution A. In 394, the digit at ones place is 4, which is less than 5. So, we write 0 in its place and 39 as it is. Hence, 394 is rounded off
to the nearest 10 as
390. B. In 346, the digit at
ones
place is 6, which is greater than 5. So, we write 0 in its place and increase the digit at tens place by 1. Hence, 346 is rounded off to nearest 10 as 350. C. In 4765, the digit at ones place is 5. So, we change the digit at ones place to 0 and add 1 to the digit at tens place. Hence, 4765 is rounded off to the nearest 10 as 4770. Rounding off a number to the nearest 100.
To round a number
to the nearest 100, we name the nearest multiple of 100. Let us revise. Example, round off these numbers to the nearest 100. A. 4345, B. 1250, C. 473. Solution A. In 4345, the digit at tens place is 4, which is less than 5. So, 4345 rounded off to nearest 100 becomes 4300.
B. In 1250, the digit at tens place is 5. So, we change the digits at tens and ones place into zeros and add 1 to the digit at 100 place. So, 1250 rounded off to nearest 100 becomes 1300.
Rounding off a number to the nearest 1000.
For rounding a number to the nearest 1000,
we look at the digit at the hundreds place. If it is 0, 1, 2, 3 and 4, we replace the digits in the hundreds, tens and ones places by zeros. If the digit in the hundreds place is 5, 6, 7, 8 and 9, we replace the digits in hundreds, tens and ones places by zeros and increase the digit at thousands place by 1. Example, round off each of the following numbers to the nearest 1000. A. 4345, B. 2780, C. 16587. Solution A. In 4345, the digit at hundreds place is 3, which is less than 5. So, 4345 rounded off to the nearest 1000 becomes 4000. B. In 2780, the digit at hundreds place is 7, which is greater than 5. So, 2780 rounded off to the nearest 1000 becomes 3000. C.
In 16587, the digit at hundreds place is 5. So, we change the digits at hundreds, tens and ones places into zeros and increase the digit at thousands place by 1. So, 16587 rounded off to the nearest 1000 becomes 17,000.